Hello everyone, my name is Surya and welcome back to my channel. In today's video, we are going to talk about taints and tolerations in Kubernetes along with a practical demo. Let's say you are working in a big MNC building. On the first floor, most of the employees sit. On the second floor, only the finance team sits. On the third floor, only the IT maintenance guys sit. Now the normal employees are not supposed to sit with the finance team or IT maintenance team in the same floor. By default, they are not allowed access to the second and third floors. Access is controlled so that only the required employees can go to their respective floors. If we translate this to Kubernetes cluster, think of the building as the cluster and each floor as a node. Inside the node, the employees represents the pods. The first node should only run pods for test cases. The second node should only run pods that require high GPU for performance tasks. The third node should run only for monitoring pods. No other pods should be scheduled on these nodes. This is exactly what taints and toleration do in Kubernetes. You apply a taint on the node and a toleration on the pod. If a pod toleration matches the node taint, then the scheduler allows the pod to run on that node. For example, if you create a taint on the node with the key value and effect no schedule, any pod that has a toleration matches the key value and no schedule effect will be scheduled on that node. Let me show you with a simple demo. First I run kubectl get nodes. Right now I have two nodes running in my cluster. What I am going to do is to create a taint on the second node. This taint will restrict the node to run only monitoring pods. So I run the command kubectl taint nodes and the second node name and then passing the taint key value with dedicated and monitoring with the effect no schedule. So this creates a taint with the key dedicated and the value monitoring and the effect no schedule. Next I verify whether the taint was applied by running kubectl describe node and the node name. As you can see, the taint is successfully created on the second node. Now I will deploy a normal Nginx pod and check where it gets scheduled. Once the pod is created, if you check the pod details, you will see that it is running on the first node. This happens because the Nginx pod doesn't have any tolerations for the taint on node 2, so it gets scheduled elsewhere. Next, let's deploy a monitoring pod using BGBox image. This time, I will add a toleration in the pod spec. The toleration I defined has the key dedicated and the value monitoring and the effect no schedule, which exactly matches the taint on node 2. After applying the manifest file, if you check the pod, you can see that it is scheduled on node 2. This confirms that the pod toleration matches the taint, so the scheduler placed it on the correct node. However, in production, using only taints and tolerations is not considered a best practice. They allow you to restrict pods at one level. If some nodes have enough free resources, it may still try to place pods there unless the taint and toleration strictly prevent it. That's why in production setups, you should combine both taints and tolerations with node affinity and sometimes pod affinity and affinity to give the scheduler more precise rules about where pods should or shouldn't go. I will explain node affinity in detail in the next video. Thank you for watching and see you on day 40.